All right, welcome back, my virtual learners here. Today we got lesson 121, and this is just a video guide. For those who have not really seen my video guides, I just work through the lesson, and I expect when I post a lesson on Google Classroom that you try it on your own and use this video guide as assistance. We have lesson 121, so we kind of are jumping into things. And where this is going to pick up is shifting shapes and different ways we can shift shapes around a coordinate grid. And the first one that we do is investigating reflections. And so we know reflections, the thing you look in a mirror and it looks back at you. And this is not that much different. This is the geometric concept of it. But we're going to kind of learn what these reflections are through trying to visualize it a little bit. It's harder to do when we're online. But visualization and investigation is going to be how we go about it here today. We're kind of skipping around, and you'll see that these are the problems that you have on the work that is posted on Google Classroom, and then your homework assignment is also these three problems. So that is just up there as a check. With that said, we'll get into the first one, which is 1-47, and it talks a little bit about spatial visualization and reflection. The beginning talks about how we invested this kaleidoscope idea in 115, which we are not doing. Not a lesson that's really applicable to move on to a virtual platform. And so we're skipping over that one and we're moving right into 121. Really what that one was just using mirrors and creating different shapes using mirrors, which introduces the idea of reflections. The bigger idea here is just picturing what's going to happen in your mind and then trying to retrace it like on graph paper. And that's going to be kind of the big point today. You'll see when I get to question 150, that's kind of the highlight question because I'm going to teach you a method on how we can always reflect over a horizontal line, a diagonal line, or a vertical line. So you'll see that coming up. And then just keep these three questions in mind as I'm talking today. All right, how do I see it? How can I verify my answer? And how can I describe it? Because when we're talking about visualization and investigating, those three questions really apply. All right. On to question 147, it says, which of these net diagrams, and so this is a net diagram, it's pretty much like if you had a cardboard box and broke it down, and it says, which below would form a box with a lid if folded along the interior line. So it's saying, which one of these boxes, A, B, C, and D, and there could be multiple, if you folded them up, would create a box with a lid. All right, and for me, I can kind of visualize what that might be like, and I could maybe say, I could try to guess on which one it would be. But the easier way to go about it is to use the link. If you copy and paste the link on, or type in the link that I gave you on the Google document form, or if you are join the ebook, which I posted the ebook material on Google Classroom. If you go to the ebook and click on the e-tool, so I'll show you both of those. We have, first of all, this is what your lesson should look like. Oh, that's the homework. This is what your lesson should look like here. You could copy and paste this link here, and this link should give you, get you to the work page where you can build these nets. Or if you have joined the ebook, you can go to the ebook and you can, you can go to the first problem and click on the 3D Nets link, and that 3D Nets link will also bring you there. And so if you notice, this is the net for the first problem. It's got that here, makes that L shape with a little top here, and that's what we have here, a little L shape with a top here. And so really what you can do then is just click and see if it creates a box. And we see that it created a box, but it has no lid. And so for A, we have does not work. A is a no for creating it. All right, and I know this seems somewhat easy, but this is just kind of introducing the idea of how we're going to use e-tools online and how we're going to use them in class as well. All right. Now for part B, we have that shape, and to go onto here, to find part B, you have to click on the top left here, you have to select net, and you have to select the next one. All right, same kind of thing. Now you see if you can build it into a box by clicking, and we see here, this one does build a box. And so we go back and we say for B, that is a yes. All right, for C, we'll go on, back on, and we'll select a new net right here. Building it up, we see we have a missing top again. So C does not work. C is a no. And D, finally, I can kind of visualize D, where I could be like, well, if I broke down a cardboard box, that's what it would look like. So I'm going to say yes right away. And that's kind of like goes back to that question in the top is like, how do you describe it? Well, I describe it as a broken down cardboard box, and that's kind of how I visualize it. But to check, I'm going to go up. I'm going to select my last net here, and I'm going to build the box, and it does in fact work. And so I was right in my assumption, and I have that box built for D, so yes was the right answer. All right, and that kind of, again, takes us past 147. We are not doing 148, and so we'll move on to 149. But again, sort of simple, gets us used to how we're going to use e-tools, and in class how we're going to use them, and kind of the niceness of the visualization there, where we could try to visualize it in our head, but we actually have the tool to do it. All right, moving on to 1-49. This is a good visualization problem. So it says, when Kenji spun the flag shown at the right very quickly about its pole, he noticed a three-dimensional shape emerge. So it's kind of a confusing wording there. But what they're saying is, like, maybe he put his hands on here, he put his hands on this pole and started spinning it around in a circle really, really fast. And so they're saying he started doing that and his eyes kind of picked up a three-dimensional shape. This is going to be a little bit tougher for me to do on the computer, but it's saying now for part A, what shape did he see? Draw a picture of the three-dimensional shape on your paper and defend the answer. Well, you got to think about this triangle spinning around in a circle really fast. And so if a triangle started spinning really fast, you would have a triangle there, and you would have, you know, there would be a triangle going back, like going back this way. There would be a triangle going out this way, and there would be a triangle coming at you. And it would be spinning so fast that the bottom of it actually would become circular. So this would become a circle on the bottom here. And then we would have this shape, and so we would end up creating this cone shape. I'll try to draw it a little bit better here, because we have the triangle spinning, which gives us that on the bottom, and then we get this where it's spinning on the back side there, and then it spins on the front side there. And so we get this cone shape, and the flagpole would go down where he's spinning it with his hands down here. And so that three-dimensional shape that he creates is what we eat ice cream out of. It would be a cone. So A would be a cone is the three-dimensional shape. Okay, the next one is, what would the flag need to look like so that a sphere, or like the shape of a basketball, we know a sphere, is formed when the flag is rotated. And so we have to think now, it's kind of working backwards from what we did. We are given a flagpole, and we need to put some kind of shape on that flagpole so that when we spin it with our hands, it creates a circle, just like the one above created a cone. All right, think about it for a second, and then I'll give you the answer, which would be, we would need to put a half circle on that flag so that when it spun around, we would end up getting some kind of sphere. So we'd have that side, and then when we spun, it would be on that side, and we'd also have that back side there and the front side there. And that would look like if you were spinning it around on that pole. Again, it is not, so I got to write the answer quick. For B, it would be, you would need a semicircle on the flagpole to create the sphere. Again, I'm not the best artist, and this is something that's not the easiest to visualize. I do wish they had some kind of resource page or some kind of e-tool for this, but it's, again, just a product on can you visualize it. If you are having problems visualizing this problem, please email me and I'll try to find a video online, or maybe you can try to find a video online and see how this kind of looks. Because again, this is a technique on visualizing, but that doesn't necessarily mean that we all can do it by just seeing it or looking at it. All right, so we'll move on to, we got our two answers for A and B. We got cone was what that triangle looked like if you spun it, and then we would need a semicircle to spin to create a sphere. Sorry. All right, 1-50, we get into reflections, which is, again, I said this problem was key. And it is key because it really starts getting into how we're going to do reflections, and it gets us into the resource page where we get to practice it. So again, we didn't do lesson 115, but there is a hinged mirror, and you put it on a piece of paper and you see how that gets reflected. We actually will do a kind of a kaleidoscope investigation later in this course, but until then, we can't really follow that. But what they're saying is just kind of, again, what does a reflection look like? How can we describe it? And so it says, the first part in question A is, why do we think the image is called a reflection? How is the image different than the original? This is a question where answers might vary a little bit just because it's open. It's not just one right answer here. So when they say, why do you think the image is called a reflection? Well, I think that image is called a reflection. So A, part 1, I'll call it. I think that image is called a reflection because it looks like what would happen if you put it up to a mirror. And so that's what I'm going to say. Again, it's more opinionated, so I'm going to say like looks like image in a mirror. All right, and I'm going to put part A2 down here, because the second part of the question is, how is the image different from the original? Well, there's different answers here too. You could say, well, everything on the left looks like it went to the right over that vertical line. I'm going to say that it looks like if you folded the original over that vertical line, that would be like the imprint. So if that original picture was covered in ink and you folded it over that vertical line and printed it down on the other side, that's the image you would get. And so that's what I'm going to say is, looks like the image has been folded over and printed. I'm just going to say has been folded just for sake of not writing so much on my computer. All right. Now we're going to get into the resource page here for part B. So the part here in the middle of the A1 and A2 is the resource page, and it should be on your paper as well. And I get timed out here on my video lessons in about 2 minutes. And so I will probably be able to do one and explain it really well, and then I'll pick up in a second video and do the rest of them. All right. And so for number 1, we need to reflect this over to the other side. And I am even just going to start by telling you the method that I use to reflect these. All right. And I just kind of call it the counting method. I haven't heard a great name for it. And really all you do is you count the number of spaces to the line and then count that space on the other side. So I'm going to do this one in red here. I have a dot there, and it takes 1 space to get to the line. And so that red dot on the other side is just going to be 1 space away, and then on this side. All right, I'll do the next one in blue. I say I have that one there, and that blue dot, that blue dot there, and then that is 2 spaces away from that vertical line, which means that blue dot has to be 2 spaces away on this side as well. All right, and then if I drew a line, a connecting line from this line to this line, I have now reflected that portion of the shape. All right, and now if I change colors again and I do maybe this one down here in green, I have 1 space away, so I'm 1 space away over here, which means my next dot is there. Down here, I'm going to stay with green. I had 1, 2, 3 spaces away from the line, so I'm 1, 2, 3 spaces away from the line again. Here, I am 1, 2, 3, so I got to go 1, 2, 3. Oh, sorry, 1, 2, 3, and I'm right here. Out here, that's 1, 2, 3, 4. 1, 2, 3, 4. I am up here. I am the same as down here, so 4. Here, I'm going to be 1, 2, 3. 1, 2, 1, 2, 3. So I'm right here again. And I can kind of finish the shape from here. So if I draw down here to here, here, here. Sorry, I know I'm working on my computer and I'll get better at it throughout the time. Maybe I'll